All right, so let's see, which one is this? This is the 4i handout, which mainly talks about something called altitudes, which you may have heard of before for triangles. And altitude is often used synonymously with the word height of a triangle. Um, and so each triangle has three different altitudes because it depends on what point you're drawing it from. Um, so the way that I think of altitude is of a triangle is kind of like the height of a mountain, where you pick a point to be the peak of your mountain, and then the side on the other side. So, like, let's say we pick A, right? We pick A to be the peak of the mountain, and that means that BC, if I extend it, that's the ground, right? So, drawing the altitude from A to side BC, the key for the height is you don't measure the height of a mountain by going down the side. You go straight down to the ground. And the key about this is that when I draw it straight down to the ground, it makes a right angle. Okay, so when you draw these in, try to make them look like you're actually getting right angles. I don't want to see stuff that looks like that and say, oh, that's 90, because it doesn't really look like 90. That looks obtuse. So do your best to really make that look like a right angle there. Okay, so what I've done, sometimes it's easier to rotate the page to sort of see how this works. I can't rotate the page, but what I can do is I can actually rotate the triangles. So here's the first triangle. Oh, let me go back to this first. This is the altitude from A to BC, from point A to side BC. So let's do one from B to side AC, and then another one from C to side AB. Okay, so let's come back over here where I can actually rotate the triangles. So if I'm doing it from B, then I think of B as the peak of my mountain and AC as the ground. So I want AC to look flat, like that. Okay, so B is the peak, AC is the ground. And then when I draw the altitude, I just go straight down. There it is, right there. So if I rotate this back, whoop, so if I rotate this right back, oh, the problem is I didn't rotate the diagram, the other thing. So let's see, it goes B to AC. It's kind of close to A here. So let's go back over here. It goes from B to AC right there. And then if you look at C going to AB over here, you can rotate your page. So let me get rid of this part. And we'll rotate. So if C is the peak and AB is the ground, you can rotate your page so it looks like that, and then it's not too hard to draw straight down from C to where it hits AB at a right angle. So in this case, it's closer to A also. So if I come back over here, starts at C, makes a right angle a little bit closer to A. Okay, let's take a look at the right triangle version. So this one's acute triangles, right? This one will be right triangles. They're all identical triangles, by the way. And then down here will be obtuse. So right triangles, if I'm going from A to BC, then A is my peak and BC is the ground. So let's come back over here. And I've got a right triangle down here, the same right triangle. And if I rotate it so A is the peak and BC is the ground, notice that the height of the mountain, let me rotate it just a little bit more. The height of the mountain from A, all I do is I go straight down, right? So it's actually side AB is that altitude right there. So it's this. That is the altitude. If I started at point B to side AC, then B is the peak and AC is the ground. So if I come back over here, and I make B the peak and AC the ground, kind of look like this. And I'm just going to come straight down from B to AC. and it'll be a little bit closer to A, you might be able to tell. So in this case, it'd be straight up. I practically have to flip this diagram exactly over. So there's the altitude. And then the last one, we'll do it from C. So here's point C. AB is going to be my ground. And if you rotate the page, or in this case, I'll rotate the diagram. So C is the peak and AB is the ground. There's the diagram. And if you notice, I would just go straight down to B. Right? That already forms the right angle. So it's side CB. So in this one, here's the altitude right here. Okay, the obtuse ones tend to be the hardest ones. So we'll do from A to side BC, from B to side AC, and from C to side AB. Okay, so from A to BC. So let me go back over here. And here's the obtuse triangle down here. So if A is the peak and BC is the ground, I want BC to look flat. Okay. Let me click on something else here to get rid of that. Okay, so BC is the ground, A is the peak. The problem is, if I measure the height of this mountain, it's kind of like a cliff, like a jagged cliff that sort of goes out over the ocean or something. Well, the height of it, you don't measure this slant here or this slant there. You measure straight down until it reaches wherever the ground would be. So in this case, you actually have to extend this side here. And where that thing hits the ground is going to be our altitude. So this thing right here is the altitude. Right? So let's draw that in. So A was the peak. BC I had to extend this way. All right, let me use a different color for that. So I use blue there. And this, where it makes a right angle, is the altitude. Okay, now if B is the peak, this one I won't bother rotating here. If B is the peak, then AC is my ground, right? And if you kind of picture rotating the page just a little bit so AC looks flat, then you're going to end up drawing this line in right here to make a right angle with where the ground would be if you extended that side. So this is the altitude there. And then from C to AB, this one I'll rotate because this one's not too hard. So this one, C is the peak, AB is the ground. Kind of like that. This one's not too bad. This one, if I just come straight down from C, it's a little bit closer to A in this case. That forms an altitude right there. So, come back over here. That's really just this. Okay, let's take a look at 2. So 2 says, write the equation of the line that has the altitude from A in this triangle. Okay, well, ABC looks obtuse to me. So if I were to think of A as the peak of the mountain, and then I extend this line, then I'm drawing a perpendicular line to that extension. So it would look kind of like this, something like that. I'm not really sure where it hits down here, but that's my altitude right there. Something like that. Okay, so what I need is, I need the equation of this line. Now, we've been doing all our equations in point slope form. So point slope form, if you remember, y minus y1 equals m x minus x1. M is going to be the slope of the altitude, so the slope of that red line. X1, Y1 is any point on my line. A lot of people might be tempted to choose this point, but I'm not positive exactly where that point is unless my diagram's 100% perfect. But I do know A is on that line. So I'm going to use A as negative 2, 7. So I'm going to go Y minus Y1, which is 7, equals whatever the slope of that red line is, x minus negative 2, so x plus 2. Now I still need the slope. of that red altitude. Well, the key to the problem is I know that I can get this slope because I have 2 points on that line. I have B is 2, 4, and C is 5, 5. So what I could do is I could get the slope of this green line right here, right over and up. And when I go across, the x's change from 2 to 5, so that's 3 over. And the y's go up from 4 to 5, so that's up 1. So now I know that the slope of this green line is 1 over 3, and it's positive because I'm going uphill. Since the altitude's perpendicular, so the slope, so here, I'll write here. The slope of BC is 1 over 3. So that means that the slope of our perpendicular line, the altitude, has to be the negative reciprocal. So I flip them, and I switch the sign. Negative 3 over 1, or negative 3. So that's what I'm going to plug in here. So the equation of the altitude from point A is going to be y minus 7 equals negative 3 x plus 2. Okay, I hope that helps a little bit, and I'll see you guys soon.